Now let's understand how does a zkApp work on Mina. A zkApp consists of two parts, a smart contract code which is written in O1.js and a user interface which the users will use to interact with the zkApp, the smart contract. Smart contract is a provable code written by using O1.js. When we run the build process on it, it generates a prover function and a corresponding verifier function. The prover function runs in the user's browser and executes the smart contract's custom logic based on the inputs given by the user, and it generates a proof of the code execution. Each method in a O1.js smart contract would result in a proof generation. The prover function takes two kinds of inputs, private and public. Private input is never seen by the blockchain. Meanwhile, public input may be stored on-chain or off-chain depending on how the zkApp is designed based on a given requirement. The verifier function validates whether a zero-knowledge proof successfully passes all of the constraints defined in the prover function using the public inputs. Mina network acts as a verifier and runs the verifier function. If a Mina address on the blockchain contains a verifier function, or sometimes also called as a verification key, then that Mina address becomes a zkApp account on the Mina network. Any transactions that do not satisfy the requirements and hence do not pass the verifier function are rejected by the Mina network, and those transactions are not allowed to update the state of accounts on the Mina network. A zkApp may contain on-chain state or off-chain state. On-chain state, as we have discussed earlier, is smaller in size. We have only 8 fields of 32 byte each available on the Mina blockchain for a zkApp. Off-chain state can be stored in an external storage like IPFS, where we only store the root of a Merkle tree or a similar data structure on one of the 8 fields of the Mina blockchain. When it comes to updating the state of a zkApp on-chain, we recall that a prover function generates a proof. Alongside it, it also outputs a few account updates. Account updates are JSON plain text describing how to update the accounts on-chain. They are passed as a public input for verifying the integrity. If the verification is successful, on-chain state is updated. Before moving ahead, we'll summarize the complete workflow of a zkApp. The smart contract is written using O1.js. The build process creates a prover and a verifier function. The prover function is deployed within the UI on a hosting service, and the verification function, or sometimes also known as a verification key, is deployed within the zkApp on Mina network. The user inputs the data on UI. These inputs may be public or private depending on the use case. Prover function generates a proof using these inputs. Alongside the proof, prover function also creates account update which details the state changes. The transaction is submitted by the user to the zkApp on Mina. This transaction contains the proof to be verified and public inputs. The account updates are also passed with other public input. These are then verified by the verifier function in the zkApp if a transaction is accepted, meaning all of the constraints of the prover function are passed. The state changes are applied to the zkApp.